Welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the US and Canada. We're doing these twice a month for now. You can catch these podcasts wherever you get your podcast, and it's also available through the Danfoss Ref Tools app. For the video version, check us out on the Danfoss North America YouTube page. Search for Controller Talk to see our video collection. I'm Dave Yoder, along with Chris Brown. All right, Chris, we need to talk about Ravens and Steelers. No? Pat, next
Your
question.
audio went out. What was that again?
Ravens and Steelers. How could that happen?
Lamar's, I think it's like 1%. He's only got one win against them since he started. So 2 MVPs and 1 win against the Steelers. Not a good look.
Well, time to change quarterbacks.
I think we might be lining up to play them in the playoffs, so we might have them 2 more times here before the year's over.
Wow. All right. Well, you're bound to beat them then.
Yeah, we'll see. 2 more shots at it.
That's right.
Yeah, frustrating game to say the least on Sunday.
Okay. Penn State plays University of Maryland in football after Thanksgiving.
Speaking of disappointing. Where are you guys at now, ranking-wise?
Rankings, Penn State's number 4.
They're still 4, so you're shoo-in for the playoff. They bumped that up to, 12 teams now? So.
At this point, yes. Yeah. I like it.
Yeah.
I like it.
I think you're a safe bet there.
Yep. Couldn't beat Ohio State, but everybody else so far.
Did see that.
Yeah.
Coach caused some grief for that. He hasn't done too well against them, has he?
No. He's got a horrible record against Ohio State and Michigan.
Yeah.
But, yeah. So it goes, you know.
Maybe he'll have another crack at him in the playoffs, too.
That is possible. Hey, when it comes to deep thoughts, I always turn to Stephen Wright, the comedian. And I was wondering if you happen to know, what happens if you get scared half to death twice?
Nope, nothing's hitting me. What is it?
It's a rhetorical question. So if you get scared half to death twice, in theory, that's it.
That's
Game
it.
over.
Mm-hmm. That's one full death.
That's right. I always knew you were good at math.
Unless you're a cat and you've got 16 more half-lives to go with. Yeah.
Correct. All right. So, hey, today we want to cover some topics. This is not going to be the long and drawn-out version, but it occurred to me that we've had some questions on compressor unloaders, and there's a couple different types, and so we'll talk about that. First of all, we'll talk about your standard unloaders before we get to the digital stuff. But yeah, the standard unloaders is just you just have a relay to control some unloading on the compressor to reduce capacity or add capacity. And the main points here are they can be wired normally open or normally closed, and they can be programmed normally open or normally closed. And you just have to verify that the programming and the wiring is all going to match correctly.
Yes.
Sometimes they don't always match in the way you wire it and the way you program it, but as long as it matches the way it works, that's the main thing.
Yep.
Yeah. So, yeah, as far as programming goes, in our 255, there was a little rectangular symbol on the screen for each unloader relay. And when that little symbol filled in, that meant we were calling for the unloader to do its compression. And then when it kind of went empty, you might say, then we were telling the unloader to shut off and have less compression.
Part load on the compressor, right?
Yeah, yep.
I think more often than not, we probably end up wiring opposite of the polarity we set in a lot of this. So, yeah, that ties into that.
It's very possible, yeah. And I always told people to, hey, get your meter on there or your amp clamp, and then you can tell if it's working correctly, if there's really any question. If the unloader relays and solenoids don't have lights or anything like that to go by.
Yep.
So that's how we handled the standard unloaders.
Mini stump Dave question. What was it 3, 4? I forget how many unloaders we could get in there on one compressor.
I think it was 4.
Okay.
I think it was 4, yeah.
But it was usually more than we ever really worried about or saw on anything. So.
Yeah. Feel free to fact check me online.
I hope I didn't steal our actual stump question later on.
You did not. That would have been too easy.
Yeah, right. Yeah, and then we've got the digital unloaders, which are becoming more popular and really more common. You see more of this than the fixed unloaders, I feel like, whether it's HFC or CO2
Yep.
on a lot of jobs today. So it's kind of replacing your lead compressors, having a VFD on them a lot of times to help with some of that capacity modulation. Really two manufacturers out there you're looking at today, Copeland and Bitzer are two of the main ones. With the Copeland, the IDCM modules, they're looking for a 0 to 5 volts. So we're not directly controlling the unloader itself with these. We're sending a modulating voltage signal to a module inside of the compressor, and it's taking that signal and using that to drive how much to pulse the solenoids in these compressors. So for the Copeland side, again, yeah, it's a 0 to 5 volt DC signal is kind of the full range that you're looking at there. So it comes off of one of our analog outputs. You have to take into consideration some, not just that it's going to be that full range that you're using necessarily of 0 to 5. So 1.44 is something we see on most of these, where if it drops below that voltage of 1.44 volts, that means that you're going to be turning the compressor off. So that has to be lined up with how we program it in our system manager. So you'll see in the system manager a lot of times that you would put say a 30% minimum voltage or minimum speed in.
Yep.
To make sure that we have at least that 1.44 volts at any point that we want the compressor to run. And if it drops below that, we know that we're not going to control the compressor regardless of anything else that we might be doing with the relay. On the system manager side itself, you also want to look at a few things with the model and the software version of the system manager. So with some of the older things, 255s, the older 800s, and even the 800A, up through the first few revisions, the setup in the system manager, you were selecting the option for VO for your compressor inverter or VFD control. The system manager technically thought you were controlling a VFD, so it would give you the analog output we needed for this, but it also came with some extra things you weren't going to see. So a bypass relay, reset relay, fault, proof digital inputs, things that are associated with the VFD, but not these digital compressors. And with our system managers, a lot of times you would have to make sure you're doing something to account for that, whether it was putting in dummy points for these relays and digital inputs, overriding them, or putting in physical points and jumping them out. But you had to do some things on top of just saying you had that VO control and assigning your analog output. Once we hit some of these more recent versions of the 800A, the touchscreen controller, specifically version 326 in the software, there's an option for digital compressor that exists that works, and that's probably good to point out too, as you would see this option for digital compressor all the way back through the 800s. But it didn't actually become functional until 3.2.6 in the 800A, so you don't want to use it in some of the older equipment.
Yeah, true.
But yeah, if you've got 326 or higher with the 800A, you can select this digital compressor option, and that really limits it to just the analog output and strips away some of those other things we know we're not using because it's not a VFD. With those digital inputs in particular, if we are using the old setup, on the proof side, you want the proof to be on and the fault to be off, and that would kind of get those things out of the way just to make sure that the rest of the logic can do what it needs to do in the compressor to drive that signal for the unloaders.
Yep. And then we come into these Copeland digital compressors on pack controllers too at times, right?
Yeah. So on the pack controllers, when you're getting into CO2 jobs, similar mindset. So we know we've got minimum voltage requirements. We know we're driving it with an analog output. So we would still do some similar setup in the pack controller. Here we have to treat this minimum voltage. We do some extra things a little differently from the system manager to make sure we lock in that minimum voltage. So a lot of times if guys are starting to see these pop up on jobs right now, they're going to see a jumper in there, and that jumper is meant to take kind of the normal control out of the compressor section of the pack controller and take whatever that voltage signal is and then feed that back into the pack controller as an input so that we can filter it, so that when we do have lower capacity requirements or if we want to shut the compressor off because suction pressure is okay, that we still lock in a minimum voltage so that we can prevent alarms and other things, fault signals on the compressor itself from popping up just because we're not sending it the voltage that it thinks it wants to see while it's in that hold state.
Right. Okay, and we can do the same thing if we have to on I/O control, but it's typically not an issue because there's enough load there that you always have one compressor running.
Right.
Some of these kind of extra programming features are done when you know things are going to shut down on you,
Yep.
and
That's a good point.
you need to restart without locking out or having alarms or something like that.
And yeah, it's good just for guys not to jump right to the conclusion when this module has the alarm light on to think that there's something wrong in the sense that there's something they need to fix. It may just be that, hey, let me just make sure that I do have a setup in place that's going to have the right voltage there when I'm not calling for the compressor.
Yep.
Yep.
Yep. And then we don't see it as often, but on the Bitzer compressors, some of those have this Siemens module that takes a 0 to 10 volt DC output from the system manager to an input to the Siemens module, and then you have to kind of find out what the requirements are based on the parts you have to work with, like what are the minimum voltages to send it, and then convert that to a percentage for the Bitzer compressors. But the idea is the same, it's just that the hardware is a little different.
Yeah, some of what I've seen recently with these IQ modules that they use for this is it's not as critical that you keep the voltage at a minimum level. Some of the documentation I looked at here recently just said if you drop below 1 volt on your signal, that's going to just lock that compressor into minimum speed or minimum capacity until you take away the request through the relay to shut the compressor off. But if you're sending it half a volt, it's not going to trigger an alarm necessarily. It's just going to lock into a minimum capacity instead.
So that's an improvement.
Better. We don't have to do as much of a workaround, you
Yep.
could say, as we do with the Copeland setup.
Yep.
Yep.
Okay. All right, so that should cover the unloader questions that we typically get and the different options that are out there. So with that being said,
Bach, maybe. I just call out Bach. Wouldn't hurt here either.
Okay.
We're hoping to see more and more of that in the market. But Bach, we do have digital unloader options on our compressors. That one's going to be unique because I'm early on here, probably a little premature bringing it up now, but we don't have these modules like we're going to deal with Copeland and Bitzer. So with Bach, we're just directly driving the unloaders through solid state relays on the pack controller. So that strips away some of that complexity with these modulating voltage signals when instead we're just directly deciding when to turn the unloaders on and off.
so it's not an analog output.
Nope, just solid state relays that we're pulsing to control the capacity the way we want it.
Like just one relay, or do you think there'll be multiple relays?
Could be, you can have two unloaders
Okay.
on those, so it could be one or two depending on the model.
And since it's a solid state relay, the amount of pulses will determine the amount of loading.
Yeah, we know it'll be pulsing at a high frequency to maintain the capacity we want on there. Yeah,
Yeah. So in the words of Steve Moss, if it's a Bach, you'll know it'll be awesome then.
exactly.
Okay, gotcha. Okay. Well, that being said, we can now move on to Stump Chris.
Again,
Yes, we'll try again. And I've gone a little bit off script on this one. So I was wondering if you knew when the first commercially available compressor unloader was developed.
oh, good gracious.
I'll at least give you a hint. It's not a Bach compressor. To the best of my research, that is. Yeah.
1986.
Well, I did my research on the internet, so it must be true, whatever the answer is.
Of course.
But no, according to published information from Carlisle, it goes back to the 60s.
Okay.
Yet they were doing it back then with relays.
All right.
Yeah.
Darn, I missed again.
We'll have someone like Steve Karnacki add up your percentages here so we can figure out what
I'm
you're...
getting sent to the minor leagues.
Take Lamar Jackson with you.
Yeah.
And then in terms of listener mail, we actually have some listener mail to talk about. And I got an email from Abraham down in Puerto Rico. He was asking some questions about hot gas defrost and case controllers and things like that. And I did email him back some follow-up questions, but one of my points was that on our supermarket website, we have a document that describes the CC550A and how to do hot gas defrost if you have relays back at the rack that you have to deal with.
Yeah.
And that's a pretty good template for how that kind of works and whether or not you have to use calculations. And I found that you have to be pretty specific. If you just want to Google it, if you're not familiar with our supermarket documents and that page, you can do a Google search on something like Danfoss AKCC 55A, AKCC 550A, hot gas defrost programming, and then that'll dial it in for you. Yeah. It seems like hot gas defrost is starting to kind of creep back into the mainstream here.
Yeah, I've probably heard of more questions and things I've heard here recently as well. I agree there.
Yep. Okay. All right, well, if you would like to drop us an email like Abraham did with a suggestion for topics or a question or anything like that, you can email us at ControllerTalkNorthAmerica@danfoss.com. Thanks for listening. Our audio engineer is Raul Garcia and mostly Maria. And Maria is here making it all happen as usual, the one-person show, as it were. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.